So in the interests of time and to make sure we do have time for questions at the panel at the end, let's make a start. So, TerraFlow, please go ahead. The floor is yours.
Thank you, Colin. So let me start presenting TerraFlow. In order to explain the technologies, I will try to explain what we can find today in our networks and what TerraFlow is proposing. So we have focused on the state-of-the-art of SDN controllers. We have observed that they are mostly monolithic. We have two different brands of SDN controllers, ONOS and Open Daylight. They are both Linux Foundation projects, and they are both the basics of many vendors SDN controllers that are on the market. We see that they are monolithic, that although the MicroONOS is claiming that they are starting to try with microservices architecture, they have not been fully disaggregated yet. So what we are proposing in TerraFlow, as I have previously explained, is a new cloud-native network operating system, which is based on microservices, which supports full network disaggregation. This provides value to the network operator in order to acquire the different network elements by itself and integrate them using the TerraFlow solution. The best distributed SDN controllers to date, they don't have meet the excessive traffic demands that are expected for beyond 5G or 6G networks. That's why we need a faster control plane. We need a cloud scale control plane that's able to achieve at least 10 times higher flow processing performance. That's something that we have seen this movement in the NFV world. So the current NFV is being brought to the cloud. That's the same that we need to be able to support in the SDN community. Reaching these SDN deployments across multiple transport networks remains still an open issue. So we have been able to integrate very few technologies altogether. We have typically the DWDM connections hand-tailored over, and then we have IP connections on top of them. We need to be able to support these multi-access technologies. We need to have SDN automation for that. So that's what we see, that today we don't have automated deployments. They are only semi-automated, and we want zero-touch deployments. This also means that we need to consider, for example, the operative system of the same network elements. That's something that we are also considering in TerraFlow. So we are not only having the life cycle of the services, or we also consider the life cycle of the infrastructure itself. Moreover, we don't have any multi-operator solution for interdomain provisioning. We are starting to explore what can be used in permission distributed ledger, using permission distributed ledgers. We think that this might be included a new interesting option for that. We don't have in SDN, we don't have security analysis on the data plane integrated to the SDN controller. We are introducing protection against sophisticated attacks, which target even the machine learning components. So we are looking at this adversarial ML topic that's being broadly studied currently. And not only the data plane, but also the control plane. So only nowadays it's only based on security and authorization access typically. So we need also to introduce the machine learning to detect attacks at the optical network and transport layers. And that's it, Colin.
Perfect. Thank you very much. That was beautifully on time. So then let us move to unless there are any questions, I don't see any. So let us then move on to the next project, Rise 6G. The floor is yours.
Thanks, Colin. So we have identified 4 key challenges for Rise 6G. The first one is the definition of node network architecture, which incorporates multiple RS. And really the RS empowered strategy for wireless communications. The idea is to consider, first of all, single users, but then also consider multi-users in terms of how we can improve their connectivity how we can improve their coverage and the reliability of the coverage. And we have a specific target of considering mobile edge computing services here, which actually are stressing more and more the uplink traffic, which actually is one of the part of the challenge we want to cover. The second challenge we have, it's a very fundamental and keystone challenge of the project, which actually on the characterization of the fundamental limits of the REST network in terms of the connectivity, the localization, the sensing, the sustainability, but also on the use of releasing validated radio waveforms for characterizing the propagation and the electromagnetic RS models. For this, we have the technical challenge of designing, conceiving, and prototype RS, so record for entire two phases, as well as also produce new realistic models for the propagation environment. The third one, it's linked to the vision I already presented before, is on the online trade between different skills may have a network. So in terms of high capacity, connectivity, energy efficiency, electromagnetic field exposure, or localization accuracy. So the idea is really to enable the network to be dynamically programming in the way you have a wireless propagation channel that you decide, and then actually in a very efficient way, you can indeed adopt the parameters of your system to the specific subset of metrics you want to optimize. And then in this case, you see in the picture, you have these boosted areas where you have a specific set of targets of quality services. And then you have, for example, you want to reduce the wastage of energy, or you want to reduce the exposure of electromagnetic fields. And that's with the use of this wireless environment as a service, you can play these trade-offs between the different potentials of the system. And the fourth challenge is really on going from paperwork mathematics, as today there's a lot of paperwork on RAS, to a realistic trials where you really come to all the problems, also including the engineering of the solution. So the problem here is in design, development, and engineering and integration of RS solution, multiple RS solution in trials. And we have identified two major trials. One, which is actually what you see on the bottom on the left, which is for the extreme coverage enhancement in train station, which actually is a very interesting scenario because you have this hybrid indoor-outdoor scenarios. And the second one is for the indoor accurate localization when we apply that for AGV logistic and industrial site, and specifically we're going to have in the site of production of Fiat in Italy. Thanks for your attention.
Let us move on to the next project, Reindeer. Please continue.
So the technological challenges that we are facing are basically expressed in the different work packages. That's why I took here on the slides our project plan. So the first work package will focus on the challenge of making sure that we will serve the applications that we foresee. So we need to analyze these future interactive applications, make sure we have the correct requirements in place, and also do some propagation modeling for the new infrastructure setup that we are considering here. I think the next one is a number of R&D challenges that are really related and that require a co-design of the distributed architectures, protocols, and processing. And we will both work on the protocols for robust self-free operation on the one hand, and on the other hand, we will also work on processing and signaling for energy neutral devices, so things that should not necessarily have their own battery and can still make part of the overall intelligent environment. Central to this, of course, is the Radio Weaves platform, where we will devise models, architectures, and topologies that have a good trade-off of, on the one hand, performance, on the other hand, of course, implementation complexity and cost. And I think last but not least, and it starts from the beginning, it's not something that will only happen in Work Package 5, but that already has started, is that we encounter a lot of hard real-life problems, such as how can we work in a synchronized way, how can we perform reciprocity calibration, how can we coordinate if we have this kind of flexible, scalable infrastructure and operate in a self-free environment. There is no one master controller there. How can we make sure that we achieve the theoretical performance that some papers have already elaborated on and is really very high. But how can we achieve that if we cannot assume that we have perfect synchronization, that we should somehow realize it and all the other things in place? So I think that's in a nutshell the main challenges we see to be covered in reindeer.
Super, thank you very much. I think that was very clear. Then maybe we can move on to the next project. We seem to be going through very smoothly at the moment. Excellent. So Marcel, please give us your view of the challenges.
Yeah, hello. The big challenge is that we have this project is to extend the cell-free concept, to extend the new generation run with the cell-free concept, to offer millimeter wave front haul to the cell-free technology, to have a common orchestration system for the fixed and mobile segments, to offer fully elastic edge computing, given that we have in our system data centers structured into tiers, and offer policy-driven privacy and security in multi-tenant infrastructures. And the major innovations in our case is to disaggregate the traditional cell-free central processing unit into different distributed units and one central unit, to decide dynamic access point clustering and adaptive coordination using beam steering and beam sharing to support the front haul, to integrate the cell-free technology with ORAN by implementing the ODU module orchestration within the mid-haul, or some advanced radio source management techniques in the near RT-RIC, to offer data-driven solutions for the optical cluster formation using deep deterministic policy gradients, to offer elastic edge computing notion in order to disaggregate and dynamically migrate application functions across the edge run to core cloud and vice versa, to design dynamic slicing using convolutional neural networks and flow level in order to trigger predictive slice configuration across different domains, to design blockchain solutions for network slicing in the multi-tenant, to offer obfuscating and integrity assurance to the data transmitted, to design representation algorithms based on the embedding propagation method in order to have provision of data protection, integrity assurance, and malicious traffic detection. And finally, probably this is the biggest deal, to have some prototypes and integrate all these solutions to existing platforms and testbeds.
Super.
Yeah.
Thank you, sir. Could I just ask, you're mentioning cell-free integration with ORAN, which, I mean, I can understand in theory, but ORAN, at least to my understanding, is more focused at 5G architecture. It's very much tied to the architecture of 5G. It's based on the current 3GP standards, building on top of that. Does that mean that you're doing 5G work here?
No, we are trying to implement, as I said, the ODU module. We will orchestrate, we provide orchestration solutions for the mid-haul, and some MAI-ML solutions are for resource management in the near RT-RIC module.
But exactly that, you know, if you talk about mid-haul and things like this, and you're talking about connections with the core and all the rest of it, it's assuming the current architecture. Now, why would 6G use the current architecture? Is it only going to be an evolution of 5G? I mean, if we do things like combine the core and the RAN, all the interfaces defined by ORAN will be no longer relevant.
But if you extend, the current 5G architecture with the cell-free concept, something new, and you can extend this.
Okay, so evolution, not revolution.
Yeah.
Thank you, sir. Okay, then let us move on to the next project. HexaX.
Thank you. My name is Patrik Rugland, Technical Manager in HexaX. So HexaX is the flagship project. So for that, we are looking very broadly on the research challenges. Some of the research challenges are inspired by the vision, so trustworthiness, sustainability, global service coverage, to look at the digital inclusion. Whereas a few of the other research challenges are looking at more technical aspects. So for instance, the extreme experience is to achieve the Internet of Senses and immersive holographic communication, for instance. Connecting intelligence is to integrate AI into the network and to optimize the network for AI applications. And the networks is to ensure that you have local areas with extreme performance, extreme reliability and robustness that can easily integrate into the wider areas and flexibly be deployed and operated. To address this, we are looking at a wide range of technical enablers, which can be categorized into three groups. So on top, we see radio performance, looking at physical layer enhancements, for instance, going to higher frequencies, looking at above 100 gigahertz up to 300 gigahertz, and potentially optical, to increase the bit rate and see how you can ensure robustness and reliability, but also how to integrate communication and sensing in the network. On the bottom right, we see connecting intelligence, where we will explore ways to implement AI for orchestration and management to optimize the performance, but also looking at the radio access network to use data-driven air interface design and looking at federated learning models to optimize the performance. And we see the network evolution and expansion will look at how the architecture can be changed, evolved and modified. For instance, looking at service-based networks, see how that can be extended end-to-end, not just in the core network. And looking at new zero-energy devices, how these can be implemented into the network. The project will also explore a few vertical scenarios, for instance, human-machine interfaces, and how they can be integrated with digital twins, for instance. So as you can see, it's a very wide range. I will not list all of these examples. And that is the brief description.
Okay, thank you, sir. What do you mean by extreme experience?
So extreme experience would be a fully immersive holographic experience where you can blur the line between the digital and the physical world. You have a full 5-sense experience with multi-user interactions would be an extreme case.
Okay, so hopefully HexaX will be able to host the next workshop we do, and we can do that in VR. I assume that's what you're offering, which is excellent to hear. I look forward to that. On a more serious note, what will this actually mean for EU leadership? The work you're doing, the things that you have identified, what does it mean for EU and EU leadership?
The idea is to set the agenda and to show technological leadership and to show that the EU will still lead the research here.
I noticed there's one other question from the audience, and that was they don't see satellite in your technology universe. How will global service coverage be achieved in a cost-efficient way without such solutions?
We are considering satellites in the global service coverage. It's not in the right figure, but yes, it will be part of the solution.
I appreciate there's only so much space on a PowerPoint slide, And
Exactly.
when you get down to 8 points, it's probably small enough. Super. Thank you very much, sir. Very much appreciated. Then let us move on to the next project. Dedicate 6G. Please, the floor is yours.
Thank you. So as I was saying earlier, as part of its 6G vision, Dedicate 6G aims to transform beyond 5G networks into a smart connectivity platform that is green, highly adaptive, ultra-fast, and dependable for securely supporting innovative human-centric applications. And as part of this vision, we focus on 4 key technical enablers corresponding to the focus areas I was talking about previously. In this direction, Dedicate 6G is working towards mechanisms and tools for dynamic migratable distribution of intelligence and computation. The aim here is to reduce energy and resource consumption and provide imperceptible end-to-end latency and response time. This includes exploiting cloud, fog, cloudlets, and diverse edge devices for collaborative computation, storage and caching, and computation offloading. Another key enabler are mechanisms for the dynamic coverage and connectivity extension through exploiting various devices such as drones, robots, connected cars, or also other mobile assets, which could be, for example, even forklifts in a warehouse. The goal is with these mechanisms to enable covering areas that cannot be easily reached, where infrastructure or additional capacity may be required, potentially only for a finite short amount of time, or maybe regular network infrastructure has been damaged, for example, due to natural disasters, as I was saying earlier. So this key enabler addresses at least partly this vision or challenge for digital inclusion through this dynamic, efficient expansion of the communication environment. Dedicate 6G aims to reinforce security, privacy, and trust in support of advanced human-centric applications by integrating and deploying an advanced artificial intelligence-based security and privacy protection framework in conjunction with a blockchain-based trust management platform for securing the distributed network ecosystem. So the idea is to assess and build trust between parties, subsystems, and devices, as well as having intelligence for detecting and preventing potential security, privacy, and trust issues. In the scope of the project use cases and pilots, Dedicate 6G will develop human-centric applications to showcase this notion of novel interaction between humans and digital systems. The idea here is to utilize AI or VR equipment, smart glasses, connected cars, robots, and drones in the scope of the various use cases and pilots. Finally, as I was saying before, Dedicate 6G will demonstrate and validate the developed solutions in a series of proof of concept pilots, which include smart warehousing. This will be tested in a warehouse of the Akinis as a logistics partner in Greece, enhanced experience, which will be tested at VTT facilities in Finland and University of Surrey in UK. Public safety, which will be tested and validated at facilities of Airbus in France. And finally, smart highway, which will be validated in facilities of IMEC in Belgium and Technical University of Chemnitz in Germany. So this is it. Thank you.
Thank you very much. You are talking about a lot of the challenges and issues which have been mentioned through the vision today, things like intelligence, AI, drones, robots. These are all fine aspects to be looking at. How much will your work be building on 5G? So where's the starting place? Is this more revolutionary or more evolutionary, what you're proposing?
No, I think from the dedicated 6G perspective, it's more of an evolution. So it's really starting from work that has already been done to a certain extent, but trying to bring it as close as possible to reality.
And what's the basis for moving the intelligence? Because surely the security and data privacy rules are impacted by the architecture.
Yeah, so the idea is that, and this will be perhaps one of the most challenging issues to work on, that, okay, while I presented these enablers separately, the challenge will be to make them fulfill their goals at the same time, if I can put it like that. So each of these key enablers, and specifically also this intelligence distribution, will have to take into account the factors also from the other mechanisms. So a decision on where intelligence should be moved needs to take into account security and trust issues, and also vice versa, I guess. So they have to work somehow in tandem.
Excellent, thank you very much. So let us then move on to the next project. Dimon, please give us your introduction to the key challenges for 6G.
Thank you, Colin. Good morning, everyone. My name is Andres Garcia Saavedra. I'm the technical manager of Project Dimon. So the figure that you can see on the screen is actually the high-level view of the Dimon concept. And as you can see first, in the data plane, we actually conceive the whole mobile network as a set of interrelated, interconnected domains, what we call microdomains. Namely, and you can easily identify here the classic domains like mobile core, the transport. Here we also have the mobile edge, which includes mid-haul or X-haul network, which we have actually, it has been mentioned before in previous presentations. The far edge, which include the front-haul network, and what we have called beyond edge microdomain, which is really the wireless environment between the antennas and the users, and which we envision as being populated with intelligent surfaces that can modify, pinging wireless signals in a controllable manner. Okay, and this is also, in line with some other projects like Right 6G, which have also mentioned, this technology, which is we believe is going to be very important for 6G. Second, in the management plane, and partly inspired by ORAN, which have been also mentioned here, we envision a set of highly interconnected controllers and orchestrators which operate in a coordinated manner, and this is very important, across different time scales, real time, typically within network functions themselves, near real time or non-real time, but always with the concept of coordination between them. And third, key concept in Dimon project is that of network intelligence, or NI, which shall take everything that we have learned so far from the recent hype of machine learning and artificial intelligence, extract what is actually useful for networking problems, and blend them together with all those optimization and control theoretic tools that we have used rather successfully in the past, and place them sometimes opportunistically in an elastic manner across the different microdomains and different timescales that I have just mentioned before. So in this way, these network intelligent mechanisms are the glue that actually connect all these controllers, all these orchestrators and network functions. And those are the key actually to help us automatize network operations while also increasing elasticity in the whole system at the same time. And finally, in Dimon, we plan to realize this concept through a set of very interesting, we believe, network intelligence use cases, which are enumerated in the table that you can see at the bottom of the slide, and which include, for example, network intelligence to control intelligent surfaces in the beyond edge microdomain that I mentioned earlier, but hopefully in a coordinated manner with actual radio access networks. Okay. but also management and control of edge resources at different time scales and in environments such as smart highways, for example. Realize smart transport data plane able of providing support to intelligence services, for instance, assisting in object recognition problems while data flows from wireless cameras to the access services that may be deployed at data center in the edge or in the internet even. Virtualize radio access networks where we shall optimize jointly the allocation of radio and computing resources. And here by computing, I not only mean general purpose CPUs, but also pools of hardware accelerators that are shared. And this is very important, the word shared across multiple instances of GNOVs of radio access points in general. And of course, you may have noticed here that this is highly in line with the ORAN view, which, as you have mentioned before, it's a 5G view. But in Demon, we believe that is the right path also towards 6G. Energy-aware VNF placement or energy-aware NFV in general, and this is also important, we believe, because it has largely been ignored the fact that virtualized network functions, despite all their flexibility, elasticity, and you name it, they're actually typically less energy efficient than their physical counterpart. And this is a problem which we really need to face while we travel towards 6G. We also consider scenarios which we call self-learning MANO, or technologies that we call self-learning MANO. And here is environments where we envision machine learning solutions that are able to learn the loss function or reward function, depending on whatever you're doing, that best fit the needs of the vertical stakeholders. So some sort of meta machine learning mechanism that learns what it needs to do as well, right? And yes, other two different use cases for network intelligence, including capacity forecasting and automated anomaly response. So we believe these are 9 very interesting technological challenges that we are going to try to address in Demon. And this is it. Thank you. Thank you for your attention.
Thank you very much, sir. Integrating ideas from ORAN. Which ideas are you going to integrate from ORAN?
Yeah, so here we actually were inspired by this idea of having a hierarchy of orchestrators that operate, or controllers that operate at different time scales. This concept of non-real-time orchestrator or controller, near real-time control, and eventually near real-time control in the functions themselves. So this idea of this hierarchy of controllers that operate at different time scales, yet they need to be somehow coordinated, is something that we got inspiration from, and we plan to apply it also in the Demon project.
Thank you, sir. Yes, no, that's quite understandable. That's super. Thank you very much for that presentation. Let us then move on to the next project. And we have AI at the Edge. Please, your presentation.
Hello again, Roberto Riggio here, Technical Manager of AI at the Edge. So one concept I want to start with is the overall vision again of the project, that is to enable end-to-end artificially enabled application in future 6G network. So the goal here is to provide application developers with the platform that is familiar to cloud native application developer, and that at the same time allows application developer to have this unified environment where all the resources appear local, despite the fact that they are distributed. Here on the picture, I have reported a very high level of architecture of the AI at the Edge project, which highlights some key concepts here. It highlights the concept that we're looking for a multi-layer cloud that spans from a centralized cloud, which could be the national data center of an operator, but could be also a public cloud, going through a far edge, which could be, for example, hosted in the central office, to the near edge, which could be, for example, hosted at hub or concentration point throughout the network. And we also consider the possibility of having computational capabilities in the end user device. And why is this? This is because application will require different deployment models. Some application will need to run in a central place with powerful machines. and will leave to the user terminal just the visualization. Many applications will keep working like this. What we envision is that in the future, more and more necessity to run AI workload at the edges will increase. One challenge here is to understand how to distribute the AI machine learning pipeline across this heterogeneous fabric and volatile fabric. So here in the slide, I'm putting an example how to distribute inference, local training, and global training, where to put them, how to do this at runtime, at static time. But there are other aspects that we will also consider. For example, how to split a machine learning pipeline from ingestion, filtering, preprocessing, modeling, and deployment. This is common in centralized setup, less common in edge computing. And here I listed the 6 main breakthroughs of the project that we will tackle. Let's say the challenges. We are looking for AI machine learning for closed loop automation. We are looking at privacy preserving machine learning for multi-stakeholder environment. We are looking at building this distributed, decentralized connect compute fabric that is converging connectivity and networking into a single platform. We are looking at this concept of artificial intelligence function, which is an elementary block of an AI-enabled application that can be combined in a pipeline, in a graph, and can be then deployed across the fabric, taking into consideration latency, bit rate, power consumption requirement. We are looking at hardware acceleration and how to embed these into the Connect Compute fabric, but we are looking also to paradigms that go beyond native cloud computing, that go beyond containers that are state-of-the-art. We are looking into serverless, into function as a service. And finally, we are looking also into cross-layer multi-connectivity, both at the MAC layer and at the PDCP layer between 3GPP and non-3GPP technologies. We are looking at the disaggregated radio access network, and we are also looking at ORAN as a technology that will in some way reach 6G. Maybe it will become part of 3GPP standards, maybe it will stand alone, but we believe it is a technology and an approach that will percolate in some way or another to 6G network. And this would be all from my side.
You know, having intelligence at various parts within the future architecture of the network, you know, near edge, far edge, and I assume core or centrally. Do we need some sort of standards for AI to AI discussions in order to the interaction between things like AI at the core and AI at the edge?
We absolutely do. We absolutely do, and this is something we plan to look into. I mean, if these pipelines are to be distributed, what we want is that each block of the pipeline is independent, can talk to each other, can have API standardized that allow information flow to go from one place to another. So proposing standard for this, let's call it control plane of the artificial intelligence function, it is something of capital importance. Yes.
Thank you very much, sir. Then let us go on to the last but not least presentation. And here we have from 6G Brains. Please go ahead.
Hello, this is Yui Zhang, and the technology also manager from the 6G Brain project. Just to echo the vision of the 6G Brains is to bring the flexible or dynamic network environment for the 6G network. So this project will be supporting mapping the digital twins of the high resolution radio night 3D mapping and location into the virtual network. So also will be support the AI-enabled NPN slicing for the 6G Brains to liberate the factory from the fixed production line into the flexible production line. So the enabling technology and also the associated with challenge will become first as a multi-agent, a deep reinforcement learning framework. And this deep learning reinforcement learning framework, DRL, will be handling the different optimization problem regards the network, including the dynamic spectrum access and joint user association and spectrum access, and also QoS aware caching and joint catch and transmission control. So at the same time, there will be associated with a challenge, including the sample efficient challenge, and also the safe learning challenge, reality gap challenge, and also dynamic environment challenge and real-time challenge. Just to echo that I just mentioned, there will be provided a real-time learning and a real-time and reinforcement learning. However, there's a big challenge associated with that, including how to mapping the real-time reward and real-time action space. And the second, enabling technology, including the AI-enabled massive D2D cluster modeling. So this will be including the dynamic precoding and also the beamforming to support a massive D2D cluster. So in this D2D cluster, you will have the super UE to coordinate the one cluster for the normal access and also the beamforming, intelligent beamforming and beam direction. And the third, there will be enhanced with a normal, a gram-free normal and also cell-free massive MIMO with the underlying within the D2D network. And this D2D network will be dynamic change via the environment, especially when the channel is dynamic change associated with it. And then the fourth will be the optimization content placing in the edge caching. So this also will associate with the reinforcement learning framework to coordinate the content for the caching optimization regards the QoS avoid. And another issue, number 5, is that enable technology is a new wave and new spectrum link, including the terahertz and also OWC. So as we know, this is a brand new spectrum. So the first challenge part for this, we don't have enough the channel modeling and the channel measurement regards the terahertz band and also OWC, especially for the indoor environment. So the first challenge will be provide and also the accurate channel characteristics for the multi-band indoor environment, especially for the changing and the dynamic environment for the terahertz and OWC, including the sub-6 GHz band. And the second challenge regards the new spectrum will be because you have a new spectrum, the performance, the waveform performance is totally different with a sub-6 GHz or millimeter wave band. So that we have the new waveform design to assure for the high phase noise and also high power ratio of the terahertz band and the OWC. And the sixth one will be the involved end-to-end directional network slicing in the management and the orchestration framework. So this will have a challenge. First, we need to have the high capacity and zero perceived latency to meet the end-to-end required 6G user case. And also the second challenge, you will need a highly flexible hybrid backbone network slicing scheme to provide to cope with the changing environment and changing the channel environment as well. And the seven, the enabling technology will have the higher accurate location and also the radar application based on the different spectrum. So we propose the technology for the localization, including the terahertz, OWC, and also a 3D angle of arrival, and also time of direction of arrival for the sub-6 GHz systems. So come together to provide the simultaneously location and mapping. Okay, so this is a technology enabling for the from the 6G point of view. Yeah.
Thank you, sir. One comment, it's a very complex picture. with many things going on, is it really even realistic that AI systems can manage this in real time when you've got so much going on?
So that's why we first propose the first challenge is a real-time challenge for the learning and also the reinforcement learning. So this environment is mapping with existing Bosch configuration at their own factory. They have a different workbench, and the different workbench will be constituted one D2D network. And the one bench, you have a super UE to coordinate the communication within the subnet or subnetwork. And the super UE will be also connect to the individual access point, will be like a IAB systems. And all this IAB will be connected to the edge to provide the edge coordinates. So in this case, the real-time learning has to be first, we need to obtain the enough trial data to provide the offline learning characteristics as an estimation or starting point for the online training. Online training will obtain the channel and the data at real time. However, there's a challenge to mapping this reality of the channel to the real channel by the estimation channel. So it's a challenge, as I mentioned.
Okay, we're looking for challenges. That's fine.
Yeah.
Okay, we have another challenge now, which is the panel session. So if I could ask people who have just presented to, if they can, put their camera on. If not, at least be there. We need to, again, be careful with microphones and keep them off when we're not talking. If you could either visually raise your hand in the picture, or if you can use the raise hand, there is this feature for raising hand. If you could do that, then I will try and see it. As I say, I do have a problem because we have so many people on the call. I actually couldn't see some of the messages before. I hope I will do better in this session. Let's see how we do. Okay, let's go to the first question. I can hear some background noise, so please, if you could mute if you're not talking. Thank you. So the first point I'd like to bring up is we were just talking about complexity. And I think as we're all aware, as we go from one generation to the next generation, we seem to always get more complex. You know, if you go from 4G to 5G, and 4G, we had hundreds of parameters coming from RAN 1 to RAN 2, and in 5G, we have thousands of parameters. So clearly things have got far more complicated, as have the number of standards. Are we going to continue this trend of ever more complexity into 6G? Or will we at some point get to that limit of what we can do with 6G in terms of complexity? And should simplicity actually be one of the key design criterions for 6G? So, floor is open. Who would like to comment on that? Sir.
Sorry, Alex Gallis from University College London. In addition to these simplicity requirements or design decision, if you want, for the 6G, there are other suggested 7 in total design approaches which need to be taken into account. In
Alex, could I stop you there, sir? Because I do want to come to your question, but I want to give it some space. So maybe we could let the people answer the complexity, and then I will come back to you and you can phrase the question in a couple of minutes, if that's okay.
Yes.
Thank you. Okay, so if we could come back to the panelists, and panelist 2 would like to, Zhu, I think you wanted to comment. Please go ahead.
Yeah, I think I just mentioned the complexity is a big issue for the machine learning and AI aspect, especially the large sets of data, especially we need sensing the channel. However, channel is a large data, the multi-band channel. Now come with the 6G, we have a different band from the sub-6 GHz and towards to the optical band. So this is a large bandwidth, a large size of multi-band channel, the computation. So for the machine learning, the most important is to sensing the channel, to abstract the characteristics of the channel. So how to simplify the channel from the large measurement data or modeling data into a simple or simplified characteristic is a challenge. And also this is the task for 6G to cope with.
Okay, thank you, sir. That's obviously one specific example. I was looking for something broader. Other comments from the panel?
I can also comment on that, Colin.
Go for it, sir.
Yes, I think that complexity is inevitable in this kind of systems. The good thing is that we have ways of handling this complexity better than in the past. That's something that we have seen even introducing these cloud native architectures that help us to solve the problems in a more distributed way. So we are not trying to fix everything in a single way, but we can distribute the problems. That's also something that also needs to go from the core, where you are taking the decisions and bringing the complexity to the edge, where locally the decision needs to be taken. So we have better ways of handling this complexity that's bringing the new networks.
Okay, I'm still looking at people answering about specific problem areas, and I'm talking about the whole system, but there we go. Any other comments from the panel? It seems not. Then I would like to return to Alex, and maybe you'd be kind enough, Alex, to hopefully in a way that's answerable, put the points that you were trying to put in the chat. The floor is yours, sir.
Yeah, just a comment. The task is to make the system simpler, not simplistic. And that's a task. Now, the question to the panel are three, which are other challenges or primitives or drivers which need to be looked at systemically. One as a bottom of all the challenges, one as a top, and one across everything. Namely, in particular, what the panel think about refurbishing, the need for refurbishing the IP layer, which underpins all the networking and computing resources across the world, in particular to move out from best effort into something like guaranteeing KPIs and programmability of addressing and many other things. That's number one at the bottom. Number two at the top, refurbishing the overall multi-domain orchestration capabilities across all the systems, challenges, operations, to make this practical, and one across, namely what are the, if you want, the design decision which need to be uniformly produced for all the solutions to make the system operational, simplistic, not simplistic, but to reduce simplicity towards a level which is manageable, as well as, more important, to integrate everything. In particular, there are 7 challenges or design challenges common across network 2030 identified by ITUT. So I would like to have your views about these 3 separate but systemic topics, from which basically all of them will enable simplicity and less complexity.
Super, thank you, sir. That's exactly what I'm looking for, less complexity. So, panel, who wishes to come in on this? They all think the question's too complex, Alex. Maybe they're right. No one wishes to make a comment? Everyone's quickly looking the other way.
I can make some comments if the others.
Well, sir, if the panel doesn't wish to comment, maybe you give us a short version of your view, Alex.
Yeah, very good. IP layers are in place for 40 years. It's a time to look at it. Otherwise, changes above would not be practical to enable the many features. Therefore, it is a must, in my view. Obviously, this is important. Second is the realization or the practicality of any solution depends heavily on having multi-domain capabilities attached to it. And in a context of multi-operation of the operators, different new value chain agents, and many other things. Therefore, this is a must as well. the fact that we have complexity, and the complexity could increase by order of magnitude, as I saw some of the figures produced so far, in particular from.
So you're on mute. Alex, you press the mute button.
Sorry, the third one, did you hear my first two?
Yes, the first two was only the last sentence. You're fine. Continue, please. If you could bring it to a close, sir.
Yeah, the last one is basically managing complexity means to ensure that we have uniform systemic design choices for all the solutions. And there are 7 principles which could be used, or at least suggested by ITUT Network 2030, and that should be applied to all the challenges identified so far. So it's creating more challenges is very important, obviously, but that doesn't complete this section. Therefore, I think that the issues mentioned by me, at least, could be helpful to move the 6G environments from the paper description to something like practical for the next 5 to 10 years.
Thank you, sir. Thank you for that intervention. Was there any response from anyone from the panel, or? I'm not seeing anything. Please, there is the chat there. The points from Alex have been explicitly made there. I would welcome responses from the panel or anyone else on that. I would then like to move on to another question from the audience, and that would be from Bernard. Please, what was your question, sir?
Yes, thank you, Colin. I think it's a very simple, maybe simplistic question. We hear a lot of innovation potential when moving into 6G, which is, let's say, brought along by machine learning, artificial intelligence, and a lot of software implementation, including massive computation at the edge. So my feeling is that this is going to explode the energy budget. And at some stage, most probably, there is a need also to work with the microelectronics industry to see how these people can help you decreasing that. Because if everything runs on top of a general purpose computing platform, I think this is going to be extremely, let's say, daunting in terms of energy budget. So how do you see these kind of links between what you propose in terms of massive softwareization of the networks and innovative microelectronics or components implementation? How do you see the link between the two, or the borders between the two?
Thank you, sir. Response from the panel? Emilio.
Okay, so thanks, Bernard, for asking this question. As you might know, I'm directing this initiative, New 6G, which actually is concerned about microelectronics innovation in 6G networks. I don't have an answer about how to do it because we're working on that, but definitely we identify critical points of that. So this approach for softwareizing and going always on virtual is not actually going for the scalable and a large amount of device. We're going to have more and more in 6G, and also in 5G, we'll see some bottlenecks about the flow of data we have and so on. So this really problems we tackle from the point of view of really a new solutions, new hybridization of materials and so on, because we really need to find another way to have much more energy efficiency. One example, if you go to millimeter waves, and then if you go to sub-terrestrial communications, you already have at least a factor 1,000 of losses of energy between the antenna and power amplifiers. So either if you go for top technology we have today, so there's really the material using today, the solution is not the best fitting today. So there's a lot of research have to be done, which is really at the beginning in this direction. So it's a critical point you're raising. Thanks for the question.
Other responses from the panel?
Vera is trying to get in.
Yeah, I also tried to raise my hand, but I'm not visible.
Please, sorry, please go ahead.
So if I may, this is Vera from Dedicat 6G. One point I wanted to raise also related to one of the questions I saw in the chat. I think part of the research will also be on finding the trade-offs. So between, for example, energy efficiency and computation and intelligence at the edge. Because on one side, we want, of course, everything to happen ideally at the same time, but it might not be possible. So we need to find the limits, perhaps the trade-offs of where do we stop with the intelligence at the edge for the sake of energy efficiency and vice versa. So that's what I wanted to say on this.
May I comment on it?
Please go ahead.
I think there are two interesting elements here. First, yes, of course, semiconductor is offering new solutions. And I think specifically new architectures that are very well fit for machine learning have been proposed and have shown to be very efficient compared to general purpose processors. So I think there is a lot of even embedded devices are becoming available that can do marvelous things with low precision and achieve good machine learning performance based on that. So I think that is an evolution that we should embrace. I think another evolution which is happening and we should also embrace is to not move everything to central places. So I think we should move away a little bit from putting everything in the cloud and go for proximity computing, because that can be much more energy efficient, avoid that you commit enormous amount of data. And we have seen already, I think in 5G, a lot of private network deployments for different reasons, also just for privacy and security, but I think also not putting everything on faraway clouds and calculating there and coming back is an energy efficient approach. So I do believe that the combination of the new architectures implemented in deeply scaled technologies combined with some distributed approach and moving away from everything central is going to be essential to realize these visions.
Thank you. Any other comments from the panel? It seems not. Then maybe I could ask Bernie Hunt to present his question, which I saw in the chat.
Yeah. Hello, everybody. My question was about the use of PDLs and blockchain type technologies, which were mentioned by a couple of the projects. Obviously, we've also very much talked about the need for sustainability and green networks. Traditionally, so far, PDLs have been seen to be inefficient and unsustainable, not only in terms of energy and computation, which is the main focus, but also use of storage and use of network capacity and network traffic for maintaining the synchronization between the ledgers. To what extent are the projects aiming to improve the performance of PDLs in these three areas, or do they see that the benefits the overall system sustainability brought by PDLs will outweigh the losses due to the use of PDLs within that? And Ricard already mentioned an answer to part of the energy use within his project. So I've got part of an answer already. But I don't know if there are also other projects that want to talk about that, or if people want to talk about the storage and network use issues as well. Thanks.
Thank you, Bernie. So comments from the panel.
Well, I answered Bernie on the chat, but just to read the comment on that. Maybe for Teraflow, we have the intention of extending the current state of art on PDLs. So we have a team of experts on PDL technologies which want to significantly reduce these computational resources by they are focusing in Teraflow in the proof of work, reducing the resources made in proof of work. Then also another thing is that applying PDLs only where it makes sense. So don't use them when we could have other kind of cryptographic solutions.
Other comments? Please, Dira.
So yes, in a sense, it's for me connected to what I was mentioning before, and also what Ricard was saying. It may not make sense to apply them everywhere. And that's again something that we need to find out during the work that we are doing in the project. So The idea would also be perhaps to try different blockchain configurations, different smart contract configurations, see where they make sense and where they don't, and potentially even come up with some best practices as a result of the work that we do in this project.
Super, thank you. Other comments? It seems not, then thank you, Bernie. Let me then come to a slightly different area. We talked a lot about ML and artificial intelligence and bringing intelligence into the network. But if we look historically, when we've tried to bring in some autonomy into the network, if we look at the work we've done on SON and things like that, we notice that there tends to be a huge reluctance from the existing operators if and when they cannot really tell what's going on in their networks, which is understandable. How can we get over that with 6G? How can we convince, well, firstly, will we be able to know what's going on in the networks if we have all these AI actors there? And secondly, if we cannot know, if it's not really determinate from outside why a decision is made, how can we get operators to actually live with that uncertainty, if you will? Who would like to comment on that?
Well, honestly, I think that's part of the revolution that we're facing. And I think the good thing is that we have a number of operators that are in this project and that clearly supports this revolution or the innovation that is coming up. Because I think, of course, clearly for operators, this is going to be asking for a stretch of mind, I would say.
Okay, you?
I think the most important for operator is to, before they deploy the AI or machine learning into the network, they need to know what's actually performance. So they need to know, or we need support like a stress testing scenario for testing the AI and the machine learning function, like against to it, like a P or test strategy before they deploy it. And this test case has to be encapsulate all the AI and machine learning activities before the real deployment. So this is actually how we can design the test case for the AI and machine learning to against the performance first in the first place. Then the operator can have a confidence to deploy it.
Thank you, sir. Roberto?
Yeah, on this point and on the other point, I think the bottom line I think we have to consider is that any machine learning solution that you will apply to a mobile network, may that be to optimize the tilt of an antenna or to optimize the transmission power of the size of a cell or the scheduling of a base station or the how to embed a service. All of this is all beautiful and very, very magical using machine learning in a way, but it cannot be better than the data that you used at the beginning to train your system. So if your data is biased, your machine learning model will be biased. If your data is partial and doesn't have enough samples of things going wrong, the machine learning model will not learn those. So the first and foremost thing before we reach to the point of deploying machine learning in production network, in 6G network by 2030, or when standardization will start in 2025, is that we should focus now in knowing how to build data set, how to build a good quality data set, labeled, that can be used for practical training purposes. Because without this, we will end up with the case of autonomous car not detecting obstacle because they were hidden by the light or misleaded by some strange picture drawing on the traffic signals. And we don't want to have this also on mobile networks.
Thank you, sir. Any other comments from the panel? It seems not. Okay, we are approaching the end, unfortunately. Let us just perhaps try one last question to the panel, which would be, What do we need to do to get 6G sovereignty for the EU? What steps do we need to take to make sure that the European Commission, or the not the European Commission, but the whole European society has access to key 6G technologies, and indeed that we have an influence on it?
If I may say, I would say two main things for me. First, we are very strong. We need to be ambitious and make our expertise, leading expertise technologically and R&D. We need to make sure we are ambitious and reinforce it. That's one thing. And this ambition is both a technical and a financial thing, of course. And I think the second thing is we should openly cooperate with all the projects and instances involved. And I'm glad to see that we have the people from Finland represented well in this call and so on. So I think cooperation, intense cooperation, so that we reinforce what we do. We don't reinvent the wheel in different projects. I think that's a second very important thing to make sure that we can have an impact.
If I may, that's Emilio. Also, I guess, linked to what I said before, we should really massively invest on microelectronic research and keep or get back the competences we had before in let's say up to 4G, because most of the knowledge we have and the capacity we have in microelectronics is migrating out of Europe, and that actually is catastrophic, because it's one of the major pillars having the hardware made, because actually at the end it's very important to have the software, but hardware is very tough to do indeed in a way that's you need huge investment and so on. So investing in a dynamic, long-term dynamic will make Europe leading for 6G.
Colin, you're muted. Roberto?
Thank you, sir.
I have a sort of deja vu feeling, because I remember being in some room at the beginning of the 5G PPP, and similar question was raised. I remember one of the answers, not given by me, but by a very bright person, was that we should focus on formation, education, and training of the next generation of engineers that will run this machine learning network. At the time, it was for programmability, because there was the huge hype on SDN virtualization. So it was said, who will run all this machinery, since telco are not used to this? So I would say that the next step will be also on training, education, formation at all level of instruction.
Sorry, may I ask you, Roberto, a question about that? How you do indeed, because actually we are speaking about sovereignty. So it means actually you only do for European people, for European citizens, that kind of teaching, education, and training, because actually otherwise your competence might fly away. How do you do?
Well, this is the competence can always fly away. I mean, the competence fly away if you cannot stay and work in a place that gratifies you. If you are in a place that gratifies you, you will stay there and you will work for that place. So it's a matter also of creating an environment that is pleasant for people to do research, to work, and to live. And I think that to live, to do research, to work, we are in a very good shape in Europe for that, if I may say so.
Okay. Obviously, it's a great sign when one panelist is asking another panelist, because it means I don't have to do anything. But nonetheless, I feel we need to bring this panel to an end. Thank you very much for everyone who's taken part. Thank you for the questions for the audience. I thought it was a very lively thing. Please don't leave the meeting right now, because we only need a couple of minutes, and there's a couple of things which I think we need to do which are worthwhile. So I'd like to just spend a couple of minutes trying to wrap things up and provide some conclusions, or at least as I see it. And then what we wish to do is we wish to try and have a group photograph where we would ask everyone to try and put on their cameras, and we will try and capture that moment to give some posterity for all the people who have taken part. So in terms of conclusions, I think it's been a very lively and very interesting workshop, at least from my view. I think the webinar has certainly shown that there are a lot of exciting 6G research already going on in Europe. And I think clearly there are certain keywords or certain technologies which are coming out. Clearly AI and ML is being mentioned widely across the project, as you would wish. And we equally have some mention of terahertz, and we also talking about use cases, lots to do with VR and drones. And I think that's a very good sign, especially when you see that we are in this, if you will, I'm not sure if bridging is the right term, but we're in between these two key partnerships. We had the 5G PPP, which set the scene for 5G, not just in Europe, but I think to some extent also globally. And we are now, with this ICT 52, building the bridge between that partnership, 5G PPP, and the next partnership, Smart Networks and Services, where we will look even deeper and invest even more money into 6G and making 6G a reality. So if we can, with these fantastic ICT 52 projects, which we've been seeing today in this webinar, if we can build on that, if we can use those as a pathfinder for 6G in Europe, and by definition, hopefully 6G globally, I think that will be an excellent result. I think the potential is there. I very much appreciate everyone taking the time to present those ideas and to present it in perhaps a non-traditional way. Personally, I think it was very successful, and I hope we can build on this going forward. I think what is important is we try and get more than just the sum of the individual projects. If we can find forums like this webinar, where we bring the various different groups together, the different projects, and we can really then make more of an impact together. So I think that's one of the things I've learned. I don't know if anyone else wants to make any last comments. David or Bernard, would you have any last comments you would like to make?
My only last comment would be many thanks for the organizers and for all those who have participated. And we just hope that this webinar is the beginning of a long series of webinars showing how Europe is good at 6G and now at setting the trends for the future. Thanks a lot.
Thank you, Bernard. And again, from my side, thank you everyone for preparing the material, standing up and presenting. I thought it was personally, I thought that was outstanding. So thank you very much indeed. Okay, then I think the only thing that remains is to ask everyone to turn on their cameras if they can, and let's see if we can capture this moment.